Okay, here we have the second of this little video sequence. You can see over to the left we have types of rock, which I've already discussed, the igneous, sedimentary and metamorphic rocks, and weathering, which we'll talk about later on. What we're really interested in right now is the rock cycle, how are all the three types of rock connected to each other. So let's start with a refresher. How are igneous rocks formed? Essentially, igneous rocks are formed either by extrusion of magma out into the atmosphere or into the oceans, giving you very clearly extruded rock material that solidifies under very, very sharp, fast conditions. If you've seen some of those videos of pillow lavas being created under the sea at places like Hawaii or off the coast of Iceland, you'll know what I'm talking about. Essentially, the rock comes out and solidifies sharp, very, very quick, meaning that crystals are very, very small, and also you could have explosive formations such as pumice, which is aerated. On the other side of the coin, over to the left-hand side of this diagram, more complexity occurs when we get igneous rock that is just intruded into the ground and then gradually might be exposed by the dark forces of erosion. And if we have a look at that section a little bit more, you can see here from this diagram that we've got a nice breakdown of three different types of rock. We've got the deep intrusive rock, which has been intruded a little way into the ground and has cooled down very, very slowly. It means the crystals that make up the rock have become large, such as the horse-tooth granites, which are found in Mont-Lazare in the Cevennes in France. If, however, the material has been injected a little bit higher up, you'll get slightly smaller crystals because cooling has been a little bit more rapid and the crystals haven't had a chance to grow. So some batholiths, for example, like Dartmoor, have got granites with 3 or 4 millimeter diameter quartz within the matrix of quartz, feldspar and mica, and that's your granite. Of course, once you get out to the top, you've got very fast cooling and you get towards the extrusive rocks. So that's igneous rock formation. Sedimentary rock formation, of course, very different. We have original rock, which is weathered and eroded, weathered by biological, chemical and physical processes, mainly physical and chemical, with biological exerting an influence on those processes, and then moved by the great fluvial, rivers, glacial or aeolian processes. The sea, of course, is just put in there to remind you that a lot of the sedimentation occurs off the coast. Either way, we get our sediments. Notice some of them are dissolved sediments. They're chemicals held within the water that they're found within. These then therefore constitute our two different groups of sedimentary rocks, what we call the clastic rocks, which contain many rock fragments stuck together, cemented in a matrix, or those that have been precipitated out of a solution, the sea, or water, lagoons, things like that. The clastic rocks then, defined by a size of particle, we go from the small mudstones with very, very small silts and clays that are just basically compacted and glued together, and they often can be broken apart depending on how hard they've been cemented and compacted. In the middle, we've got the sandstones, and typically sand has got a diameter of 1 millimeter, so you can see the individual grains of sand in the matrix. And then finally, the breccia. A breccia is, if you like, the cookie dough ice cream, very, very large nuggets of cookie dough cemented together by the glue of calcite or silicates. Okay, so that's one way of defining or subdefining our clastic groups. On the non-clastics, we get the chemical processes of precipitation that give us things like gypsum and rock salt and limestone, and then finally, biologically, we get the layering of organic matter, which will become peat and possibly ultimately become coal. The third group of rocks, of course, are the metamorphic rocks. And here we have protolith, the original rock, which has been bent or cooked up in some way that it changes from being a sedimentary nature to being more crystalline, more massive. And here are 4 examples of how this can occur. First of all, an intrusion of very, very hot rock. It cooks up the sediments around it, turning limestone to marble and sandstone to quartzite. Very, very clear differences there. Regional metamorphic rocks, however, occur when very large areas of sediment may be dragged, for example, down into a destructive plate margin, and there the accretional wedge actually means that over a very large area, rather than contact diagenesis, you get a regional diagenesis. Diagenesis is the name of the change of state from sediments to metamorphic rocks. 2 other examples. Here's a great example, the classic Himalayas, the Tethys Sea being shrunk and the Himalayas growing in between. And what you end up with there is a lot of warping, a lot of folding under pressure. That warping and folding and pressure, so not intrusion and not hot stuff, but that warping and folding and pressure, and I feel a little bit like Mike Tyson, that actually creates the pressure that can do the cooking as well. But again, the same thing, a regional diagenesis. Okay, so those are the 3 types of rock. How are they connected? Well, you've probably got the ideas already, but essentially your igneous rock, moves to be your sedimentary rock, which can be cooked up to form your metamorphic rock, and then you've got arrows that connect. So here's the moment when I say, or your teacher says, there's a question in red over there. Why don't you think about it? So I'll give it a little Pavlovian bell, ding, and you can pause. If you go back, you'll find the answers. If you go forward, there they are, look. And you can see here, there's your graphic down the bottom. We can see that igneous rocks are weathered and eroded to form sediments, which are then compacted and cemented to form sedimentary rock, which could be heated to form metamorphic rock, which might melt at a destructive plate margin to help add to the magma, which may come up as igneous rock, etc., etc. And then in amongst those, of course, we have interim stages where the sedimentary rock will be weathered back to sediments. The metamorphic rock will be weathered back to sediments. Likewise, some igneous rock can create heat and pressure, creating metamorphic rock. And that is your rock cycle. There it is, nice and simple. Last video to do will be weathering rocks erosion, but for now, go back and have a look at it. Make sure you know it. Get a good glossary. I thank you all.